Hey guys, welcome back. Now here in this video, I'm going to show you as how you can access the individual layers in TensorFlow model. The reason this is very important because oftentimes when you're working with complex deep learning models, I want to have a better control over each and every layer. I want to make sure that I'm setting this a specific layer as a trainable, and I also want to make sure that I'm not I'm making sure that some trainables models are freezed. That means I want to switch off the training for some layers. Now in such scenarios, it is very important to know as how we can access the individual layers once we have defined the model with TensorFlow. Now to understand this concept, here I already have my model defined. So this is the model. So my model intuitively looks something like this. It has an input layer, and this input layer is connected to two hidden layers. And after my two hidden layers, I'm having an output layer. Now the input that I'm going to take, so this input is of the shape 25 by 25 by 3. So before I send this to my input layer, I'm actually performing the flattening operation. Now intuitively, in the same manner, I have defined my layer as a sequential. So I have performed a flattening by specifying my input of the shape 25 by 25 by 3, and this is followed by hidden layer definition. So 4 units of neurons, and activation is ReLU, and the same applies for this layer 2 as well. And this is followed by my output layer with a single neuron with activation of sigmoid. And finally, I have displayed the summary of my model. And once we have the model defined, now let's see how we can access the individual layers. Now, if I want to access my individual layers, I can access by calling the layers attribute. Now let me do one thing. I'll say models.layers. Now, once I call it like this, so this is going to tell me as what are all the layer objects that we have. So on my first, I'm having a flattening object layer, and there is another dense layer. This is followed by dense layer, and there is another dense layer. Okay. Now, if I want to access a particular layer, as you can clearly see when I call this model.layers, this is returning me in the format of a Python list. Now, if I want to access the individual layer out of it, obviously I can just make use of the concept of indexing. Now let's do one thing. This time I want to access the first hidden layer. Okay. Now if I want to access the first hidden layer, I'll display again model.layers. So my first hidden layer is having the index position as 1. So I'm going to say that, okay, hidden 1 layer is given by model.layers, and I'll specify the index position as 1. Now I'll just execute this. So this is going to select that particular hidden layer. Now once I have selected this, now if I say, okay, let's do one thing. I'm going to call the name attribute for my hidden layer. So if I call it as h1.name, it's going to tell me that this is a dense layer. Okay, so this is a dense layer because that is what has been given over here by default for me. So if I extract the next layer, it would give me a name of this layer as dense_1. Or if I wanted to have my own name, I could have specified during the layer definition. Okay, so here I've mentioned my name as hidden1. Now after I specify this name as hidden1, after specifying my activation, so we can clearly see that the name hidden1 is present over here. And if I access this h1 by specifying the layers at index position 1, so the name is hidden_1. Okay, so we can now access a particular layer from a given neural network. Now there is another way to get a layer, guys. Now suppose if I am aware of this hidden layer name, then in that time I can actually get my layer. So in order to get the layer by referring its name, I can say that model.get_layer, and then we can specify the name of a layer. So I know my name, so my layer's name is hidden1. So if I just execute this, this is going to return me that dense layer, guys. See, this has actually returned me that dense layer. We can confirm the same. I can also say that, okay, model.get layer hidden1, whether it is same as my hidden1, that is h1, and if I simply execute this, I'll get the boolean output that would say as true. So that means if I want to retrieve any layer, then at that time I can specify its index position by calling model.layers, or I can specify its layer name and get that particular layer which is of my interest. Okay, now once I have got a particular layer, the common thing that we want to analyze is we want to visualize as what are the weights and bias terms that has been initialized for this particular layer. Now if I want to do that, the way that we can do is we can say h1.get_weights. Now h1.get_weights is going to return us our both weights and bias terms. In order to get the better clarity of the shapes that we are getting over here, so I'll say as weights comma bias term and h1.get_weights. Now I'll just execute this, and if I display w.shape, and I'll also display b.shape, guys. So I've got the output of w.shape as 1875,4. Now this clearly means that my each input that I'm getting for each neuron, so it is having its own respective weights. If you had observed earlier, my model has 4 neurons in my hidden layer, and it is receiving the inputs which is of the shape 1875. So 1875 is the input, and 4 is the 4 hidden layers that I'm having or 4 neurons that I'm having in that hidden layer. So 1875 into 4, those many number of weights that we have in our neural network, especially in my first hidden layer. And each neuron is having its own bias term, and that is what is being displayed over here. Okay, now to get the better understanding, let's do one thing. Let's take an example data. I'm going to define my x as a tensor, and this x is a TensorFlow tensor which is defined as tf.random.normal, and I'll specify the shape, let's say 1875, because I want to test out on this hidden layer h1. So this hidden layer h1 expects the input of the shape 1875. So I'm defining my tensor, which is a tf.random.normal object which has the shape as 1875. Now what I'll do is I'll apply this x. Now before I apply, let me display my x. So this is how my tensor x would look like. So it has 1875 shape, and this is how it would look like. Now what I'll do is I'll apply this input x on top of my hidden layer h1. Now if I'm applying this input for my neural network, one of the common way my neural network expects is it expects in the type of batch size comma my input shape. So in our example, I already have only one input, so only one input is present. Now if I'm sending this one input, I have to make sure that I'm specifying the batch size over here as the first argument, and then I'm specifying my input data as my second argument. So I have to add a dimension along the axis is equal to 0. Else I'm going to get an error. To show you what it would mean, let's do one thing. I'll say h1 of x. That means I'm applying the input data of x on top of my hidden layer h1. Now if I just execute this, I'll get the output, that is the value error. It says input 0 of layer hidden 1 is incompatible with the layer, because it is expecting minimum dimension as 2, but I'm just specifying only one dimension. Now in order to fix this, we have to add one extra dimension along the axis is equal to 0. Now if I want to do that, obviously we have expand_dims method, just like we have in NumPy library. I'm going to specify it as h1, and inside the parenthesis I'll specify tf.expand_dims, and now this expand_dims takes actually two important inputs. They are input, that means what is the tensor that I want to add a dimension, and I also have to specify the axis. Okay, in which axis I want to add a dimension. Now in our example, I have to specify an outer batch dimension. Hence, I'll be specifying it as axis is equal to 0. Alright guys, so I'll say tf.expand my x, that is my tensor, is the input. So the axis is equal to 0. Okay, let's do one thing. I'll just call only this part and let's observe the shape that we are getting. If I just display the shape tf.expand x comma axis is equal to 0, as you can clearly see, this is returning the tensor of the shape 1,1875. Now I'll apply the same thing inside my h1 as an input. See, now if I just execute this h1 layer is actually returning me 4 outputs, which means each neuron is returning me an exact single real value. So this neuron is having the output as 0.6566. This is 0 and 0. Maybe it is less than 0. Since we are using the activation function as ReLU, we are actually setting it to be equal to 0. And in the fourth neuron, I am having the output as 2.580. Now, if you are running in your own system, you might receive a different output. The reason because each time when you are defining a layer in your own system, it will have its own initialized values of weights and bias terms. So when you run it, you might get a different output. But the core expectation is when you run this command of h1 of tf.expand with this random tensor x, you should at least receive 4 outputs. Alright guys. So in this video, we have seen as how we can access the individual layers when we create a TensorFlow model, and also how we can explore further and understand how to retrieve that particular layer and what are the various methodologies that we have. So we can retrieve a layer by calling model.layers and get a respective layer that we want using the concept of indexing, or we can get the layer by specifying its layer name as well. And to get its weights and bias terms, we call this get underscore weights method on top of our layer. This is going to return us the weights and bias term. And we have seen in depth as how we can actually apply an individual layer to an example data. I hope this has been useful to you. Do let me know what you think about it in the comment section. So if you want more such content, please subscribe to our channel. I'll see you next time. Take care.